This video covers Coulomb's law. Coulomb's law is this relationship, which states that the attractive or repulsive force between two charges is equal to the product of those two charges multiplied by the electric force constant and divided by the distance between the two charges, squared. This formula is very similar to the gravitational force equation that we covered in the previous chapter, but instead of dealing with very large numbers, Coulomb's law typically deals with very small numbers. Let's do an example. We want to find the force exerted on the electron by the proton in a hydrogen atom, where the separation distance is 5.3 times 10 to the negative 11th meters. So we know that we're probably going to have to use our Coulomb's law equation, and we can fill in the electrical force constant, and we also know that the charges of an electron and a proton are the same, which is 1.6 times 10 to the negative 19th coulombs. And you notice here that even though an electron is negatively charged, we still put in a positive number. And instead, we take into account that one is positive and one is negative later if we're asked if it's an attractive or repulsive force. We knew that the distance was 5.3 times 10 to the negative 11th meters. And when we plug this in, we find a force of 8.2 times 10 to the negative 8th newtons. We can also be asked what the velocity of the electron is. And we know that the force is equal to the mass times the acceleration, and that since the electron is orbiting the nucleus, the acceleration is equal to the centripetal acceleration, which we learned is equal to the velocity squared over the radius. And we know these following variables, and we can see that the electron's velocity is 2.2 times 10 to the 6 meters per second.